Our star, the Sun, seems so constant, a reliable source of light and warmth in our vast cosmos. Day after day, it rises and sets, painting the sky with its golden hues. We often take its presence for granted, never truly considering the dynamic forces at play beneath its seemingly placid surface. Life-giving, warm, and bright, it nurtures our planet, allowing life to flourish in countless forms. The sun's rays kiss our skin, providing us with essential vitamins and a sense of well-being. But beneath that calm exterior is unimaginable violence, a constant churning of energy and magnetic forces that dwarf anything we can comprehend on Earth. It's a realm of plasma and magnetic fields, where temperatures soar to millions of degrees. On July 15, 2025, our satellites witnessed a spectacle, a dramatic event that underscored the sun's raw power and its potential impact on our solar system. A chasm of fire, 250,000 miles long, an immense scar tearing across the solar landscape, ripped open across the sun's surface, a testament to the immense forces at play within our star. This wasn't a subtle crack, it was a cataclysmic rupture. Imagine a canyon so vast, stretching across a significant portion of the sun's face. It could swallow Earth 30 times over. The sheer scale of this event is almost impossible to grasp. It puts our own planet's geography into stark perspective. This was not rock, but a river of superheated plasma, an electrically charged gas flowing along magnetic field lines, millions of degrees hot, hotter than anything we can experience on Earth. This extreme temperature gives the plasma its characteristic glow, a visible manifestation of the sun's immense energy. It began with a dark, snaking line, a seemingly innocuous feature on the sun's surface, a solar filament, a structure that holds the key to understanding this dramatic event. Growing for days on the sun's southern hemisphere, slowly building in size and potential energy. These filaments are massive structures composed of dense plasma held aloft by intricate magnetic loops, of solar material suspended by twisted magnetic fields, like a tightrope walker defying gravity. But those magnetic bonds can only hold so long, and the tension builds relentlessly. Suddenly, the magnetic cage shattered, unable to contain the immense pressure any longer. The filament erupted, propelled outward with incredible force, unleashing a blinding flash, a solar flare that radiated across the electromagnetic spectrum, and a wave of energized particles into space, a surge of radiation hurtling outwards at tremendous speeds. NASA's Solar Dynamics Observatory captured every moment, providing us with invaluable data and stunning visuals of this event. As the filament lifted off, a slow-motion ballet of plasma and magnetic fields, carving a fiery trench, the canyon of fire, a dramatic scar left in the sun's atmosphere. A colossal cloud of charged particles, a vast expanse of plasma ripped from the sun's corona, billions of tons in mass, was ejected, hurtling outwards into the solar system as a coronal mass ejection, or CME, and raced outward, carried by the solar wind. Its path through the solar system, a trajectory that could potentially intersect with Earth, became an urgent concern for us on Earth as scientists tracked its progress and assessed the potential impact. The images sent back are both beautiful and humbling, capturing the raw power and majesty of our star. They reveal the sun's true nature, a dynamic and ever-changing force that shapes our solar system. Not a gentle lamp, but a raging nuclear furnace, constantly converting hydrogen into helium and releasing vast amounts of energy. The canyon glowed with an eerie light, a spectral luminescence born of extreme heat and magnetic forces. A scar on the face of a god, a reminder of the immense power that resides within our star. This event is a stark reminder of our place in the cosmos and the forces that constantly buffet our planet. We live in the outer atmosphere of a star, the heliosphere, a region of space dominated by the sun's magnetic field and solar wind. Subject to its moods and outbursts, its cycles of activity and periods of relative calm. Understanding these events is not just science, it's survival, a critical step in protecting our technology and infrastructure from the potential impacts of space weather. The energy that created this canyon is now traveling through space, radiating outwards in all directions. A silent, invisible threat, a potential hazard to satellites, astronauts, and even our power grids on Earth. Under the right circumstances, if the CME were to directly impact Earth, it could reach out and profoundly disrupt our world, causing widespread power outages, communication failures, and damage to orbiting satellites. The sun's fury is never as distant as it seems, and vigilance is key to mitigating the risks of space weather. What was this cosmic serpent writhing across the face of our star? What force could possibly be at play to create such a dramatic display in the vast emptiness of space? A solar filament. These structures are truly awe-inspiring. Picture a rope of plasma, a superheated, electrically charged gas, hot, electrified gas, so hot that it glows with an intense light, a light far beyond anything we can experience on Earth without specialized equipment. This rope is suspended high above the sun's surface, defying gravity, held in place by powerful and complex magnetic fields. These fields act like invisible tethers. These filaments can stretch for half the solar disk, an immense distance when you consider the sheer size of the sun. From our perspective, they appear as dark threads against the sun's bright face, a stark contrast that makes them visible. They're essentially clouds of plasma, immense and dynamic. These clouds are held aloft by invisible magnetic forces battling against the sun's immense gravity, but they're fundamentally unstable structures, constantly storing vast amounts of energy like a coiled spring. All this energy is waiting for a trigger, a disruption in the magnetic field. When the magnetic field lines become too twisted and stressed, they can suddenly snap, a process called magnetic reconnection, a fundamental process in plasma physics that releases tremendous energy. When this happens, the filament erupts in a spectacular fashion. It's launched into space at millions of miles per hour, an incredible burst of energy and matter. This eruption is often accompanied by a solar flare, a sudden flash of intense radiation, and it often gives birth to a coronal mass ejection, or CME, a massive expulsion of solar material. A CME is a billion-ton blob of magnetized gas, a truly colossal amount of material. This blob carries the sun's magnetic field far out into the solar system, influencing the space environment around planets. That dark thread, that seemingly insignificant feature, is actually the seed of a potentially powerful solar storm. A beautiful spectacle when viewed from afar, but one that can become a significant hazard for our technology and infrastructure in space and on Earth. The demise of a filament, this dramatic unraveling, is often the birth of a solar storm, a key element of space weather. The scale of this eruption, it's hard to truly wrap your head around it. We're talking about forces and dimensions that dwarf anything we experience on Earth. Is almost beyond comprehension. It challenges our everyday understanding of size and energy. To even begin to grasp it, we need to shift our perspective entirely. The filament, that ribbon of superheated plasma, was 250,000 miles long. Imagine that stretching across space. That's over 30 Earths could fit inside it, lined up one after another. Think about the sheer volume of space that filament occupied. If placed between Earth and the Moon, this single structure, it would bridge the entire gap. It's a distance we often think of as vast, but the sun makes it seem insignificant. The CME, or coronal mass ejection, ejected billions of tons of plasma into space. That's thousands of times the mass of every building, every structure, car, and ship on Earth combined. All the infrastructure we've built, dwarfed by a single solar event. It moved at a speed and incredible velocity that could reach the Moon in mere hours. A journey that took astronauts days, completed in hours by this solar outburst. This is a cosmic tsunami, a wave of energy and particles, not a gentle breeze. It's a stark reminder of the power the sun holds. The energy released equals billions of hydrogen bombs exploding at once. That's more than humanity has ever produced in its entire history. An unfathomable amount of energy unleashed in a single event. The sun flexed its muscles, a display of raw power on a cosmic scale, leaving a temporary scar on its face. A blemish that, in reality, is a testament to the immense forces at play. Our storms, the hurricanes and tornadoes we fear, are nothing compared to this. They are mere ripples compared to the sun's tidal wave. These images remind us of our smallness, our relative insignificance in the face of such power and fragility. Our planet, a delicate blue marble, vulnerable to the sun's whims. We live in the shadow of a giant, a star that dominates our sky, our ultimate source of life, the engine that drives our planet's climate and ecosystems, and a source of immense, unpredictable power, a power that can both sustain and threaten us. The Canyon of Fire is a lesson in cosmic humility, a reminder that we are not the center of the universe. We are part of a much larger, a far grander, wilder universe. A universe filled with wonders and dangers beyond our wildest imaginations. How does the sun hurl a piece of itself into space? It starts deep within, where churning plasma generates tangled magnetic fields. These fields poke through the surface as sunspots, twisting and stretching like giant rubber bands. Sometimes they trap plasma, forming filaments. Tension builds until the magnetic field snaps. Magnetic reconnection. The stored energy is released in a violent explosion, a solar flare. But the flare is just the beginning. The same explosion catapults plasma into space. A coronal mass ejection. A billion-ton cannonball of magnetized plasma is launched into interplanetary space. This is the sun's fury, unleashed. Why does a solar storm matter to us? Our civilization is wrapped in a web of technology uniquely vulnerable to the sun's outbursts. When a CME hits Earth's magnetic field, it triggers a geomagnetic storm, a storm of electricity and magnetism. Power grids are at risk. Induced currents can overload and destroy transformers, causing blackouts. Satellites can be damaged or disabled, disrupting communication, weather forecasting, and GPS. Without GPS, navigation, finance, and logistics could grind to a halt. This is not science fiction, it's a real, documented threat. The auroras are the visible sign of this cosmic collision, a beautiful display but also a warning our magnetic shield is under assault. Our technological civilization faces a potential crisis from the heavens. The Canyon of Fire isn't an isolated event. It's part of a larger, intensifying pattern of solar activity. We're in solar cycle 25, which is more active and unpredictable than expected. In May 2024, a series of storms produced the strongest geomagnetic event in over 20 years. Auroras seen as far south as Florida. GPS systems failed, and power grids showed irregularities. The Carrington event of 1859, the most powerful on record, set telegraph offices on fire. If such a storm hit today, the consequences would be unimaginable. The Canyon of Fire is just the latest chapter as the sun builds towards solar maximum. Each eruption is a new roll of the cosmic dice. We are living in an era of heightened solar danger. How do we see a canyon of fire on a star 93 million miles away? Our robotic sentinels, spacecraft like SOHO and NASA's Solar Dynamics Observatory, are our eyes on the sun. They observe the sun 24/7, in wavelengths invisible to us, revealing magnetic structures and plasma dynamics. SOHO's coronagraph blocks the sun's glare, letting us see CMEs as they erupt. SDO captures high-resolution images, tracking sunspots and unstable filaments. These missions give us unprecedented understanding and crucial early warning. When a large CME is detected, scientists model its path and alert power grids, satellite operators, and airlines. This information buys us time to prepare, rerouting flights, protecting satellites, and bracing the grid. Our sentinels don't just give us knowledge, they give us a chance to act. Watching the sun is our first line of defense. Solar Cycle 25 matters to everyone, not just scientists. The sun's activity now directly affects our global society. Predictions of a weak cycle were wrong. This one is stronger and more dangerous. Our reliance on GPS, the internet, and satellites has never been greater. Our power grids are more interconnected and fragile. More solar activity means more chances for a major event to hit Earth. The Canyon of Fire is a warning. These events are becoming more common. It's not if, but when, a powerful storm will strike. Understanding the sun and hardening our infrastructure is critical. Solar Cycle 25 is a test of our resilience. The Canyon of Fire forces us to adopt a cosmic perspective. We live in the extended atmosphere of a variable star, shielded only by our magnetic field. The sun's moods shape our world, for better and for worse. We are stardust, our very bodies forged in ancient stars. But we've built a civilization of delicate electronics next to a volatile engine. Ignoring the sun's behavior is a growing risk. Understanding solar storms is essential for our survival. The quest to unravel the sun's mysteries is a quest to protect our future. The next time you feel